Looks good.
All right, so my name's Gracie, and I'm going to be working with Clay and Jacob to talk to you guys today about shifting species ranges in marine ecosystems. We're going to be looking at drivers, current status, and implications to both ecosystems and human fisheries.
To start us off, what is a species range shift? It is a shift in distribution of a species beyond their biological range, so beyond where we would normally find them. Shifts in species abundance often result in winners and losers. So winners being able to maintain or even grow in abundance while expanding their range, while losers drop in population size and in distribution range. It is a complex problem with many factors at play, including climate change, species interactions, and fishing patterns.
So when we're thinking about shifting species ranges and its cause, climate change is the main driving force. And as this conversation continues, you guys know the basis of climate change, but essentially increases in atmospheric greenhouse gas concentrations due to excessive burning of fossil fuels are resulting in higher absorption of carbon dioxide by oceans. So we've seen a huge increase in atmospheric carbon concentrations since pre-industrial levels. So currently we have 413 parts per million in the atmosphere, and that was measured really recently as compared to 270 parts per million in the 1700s. And this has resulted in an increase in ocean surface temperatures of roughly 0.76 degrees Celsius in the last 150 years, which doesn't seem super drastic from our point of view, but when we consider the stability and consistency of ocean ecosystems, that's quite a significant change. And looking into future predictions for ocean surface temperature changes, we could see an increase in temperature up to 4 degrees by the end of the century, which is very significant. And in considering the relationships between species physiological limits and temperatures, these changes in temperatures are what is driving species out of their natural ranges and causing these species range shifts. So when we're thinking about where this is happening in the world, given the fact that climate change is affecting the entire biome, there really is nowhere on this earth that isn't influenced by shifting species ranges, but there is unequal influence over the globe. So what we're seeing is poleward shifts in species ranges. So roughly 75% of the monitored species ranges are shifting in poleward directions. So we're getting species moving away from tropical low latitude regions and into high latitude cold water regions. And the reason that this is happening is because the water is warming, right? So species are looking to find cooler water areas. And in British Columbia specifically, this is having pretty significant influences on ecosystem impacts and community structure. So an example of this is with the Manila clam, which is an invasive species that is initially from Japan, but it was predominantly in the Californian coast. But with the increase in ocean surface temperatures, we're seeing it move north in location, and it's now competing with British Columbia's native Pacific little neck clam, and that's creating some different alterations in trophic levels. So overall, this issue is going to have large impacts on changes in species assemblages and trophic order. And there are a few different factors that change the vulnerability of species. So latitude is a big factor influencing vulnerability. High latitude areas are particularly vulnerable to shifting species ranges. And this is because tropical regions, all the species in tropical regions are being forced to high latitude regions. So this is going to create a high density of fish populations and other marine populations in these high latitude areas. So there's going to be increased competition in these areas and shifts in community structure, like I mentioned. And something adding to this is the increased dominance of warm water species, which is being seen. So basically, warm water species are becoming more successful, and this has to do with their physiological ability to deal with warm water. Cold water species are also particularly vulnerable to the issue of shifting species ranges, and this is because they have a narrower temperature preference range compared to warm water species. So within their physiological limits, they have a lower range of temperature that they can survive in. Additionally, just because they are located at higher latitudes, cold water species have less area to move because they're already at high latitude. So they can move towards the poles a little bit, but there's just less area for them to move.
So in terms of species, wait, can you hear me? Okay, cool. So in terms of species range shifts that have already occurred, there's a number of different examples you can look to. One example is the absence and introduction of kelp species into areas where they previously were and now are. So for example, in Antarctica, there are species of kelps moving into new areas as ice shelves are melting into the ocean. And with warming temperatures, they're becoming more favorable. So you're seeing the establishment of new aquatic communities, which you weren't seeing before. And then on the other side of that, there are kelp populations, say in Southern California, that used to exist, but with warming ocean temperatures, kelp require a very specific set of parameters in order to survive. Those parameters are being exceeded, and now those kelps are moving out of the area because they can't survive. And this isn't just specific to kelp populations. You're seeing this in all sorts of different organisms. You're seeing it in pelagic fishes, where they've been seen to no longer drift as far south as they used to, or north, depending on which half of the Earth you're on. And they're also, as we were stating before, moving towards the poles as they're searching for a more favorable thermal environment. You can also see it in cephalopods, such as the Humboldt squid, arthropods, such as the American lobster, and starfishes, such as the cushion star, which have also all been found to be moving polewards in their ranges. And the important thing to remember here is that just because it's happening in these specific species doesn't mean it's not happening in other species, because they're being, oh, can you go back to the previous slide? Just, yeah, okay. It doesn't mean they're not happening in, they or haven't happened in other species. Measuring these range shifts takes a lot of work and a lot of data. So you can't always measure the ranges of each individual species in order to determine that their ranges are shifting. You can go to the next slide. Okay, so the current situation and the prognosis for the future. So the examples I already mentioned are examples of species that have already shifted, but it's also important to remember that they're currently shifting. This isn't like a process that has already happened, it's ongoing. And unfortunately, because the oceans are still warming, the prognosis for the future isn't great. And with ocean warming, it's just gonna the changes are gonna become more drastic, and they're gonna increase in scope as more species are affected. Yeah, and again, we were talking about how range shift is generally tied to the thermal environment. So as long as that keeps going on, there's unfortunately not a whole lot that we can do because we can't really reverse ocean warming.
As we've mentioned before, climate change is primarily driving species range shifts. So the obvious solution would be to reduce greenhouse gas emissions. However, according to the IPCC, even if we were to halt all emissions, global temperatures would not decrease, but will continue to increase and then plateau due to the long lifetimes of greenhouse gases. Okay, kind of grim news, so we have to focus and look at smaller scale solutions. So highly mobile species can move themselves to more suitable areas, but sessile organisms cannot. So this creates a desynchronization in species composition. Why might that be bad? The bladder wrack, for example, is a foundation species and is home to many organisms, including many juvenile fish, as you can see in the slide there. So if these more mobile species, such as the fish, were to shift their range, they would find themselves without a nursery for their young. So using models to predict and pinpoint areas of priority, such as in this example, is really helpful in determining what steps to take and where. When species undergo range shifts, it is highly unlikely that the entire population can move into the new area all at once. So what this means is that there will be partial populations in the new environment where they can basically act now as smaller individual populations. This will drive up the risk of extinction due to them having less genetic variation. A solution to this is we can introduce individuals who are better adapted to these conditions to hopefully integrate more genetic variation into the at-risk populations in a relatively quick way. Finally, let's look at fisheries. So fisheries will have to follow the poleward shift of their target species. However, they cannot really predict exact timing and location of these shifts, so they'll experience a lag in response. A possible solution to this is that they can switch to another species, which that can help them hold over until they catch up to the range shift, or until they fully transition to the new species, given that the public is okay with eating the new species.
Okay, so just in summary, unfortunately, this is all tied back to atmospheric carbon output, and that directly leads to warming ocean temperatures. So as a response to this, species are moving polewards in search of more suitable thermal environments. And since there are many new species being introduced into higher latitude ecosystems, these will cause these ecosystems to be unstable and change the makeup of those ecosystems. And there needs to be further modeling and research into these areas in order to fully understand the impact that this will have.